Hello, good morning, evening, afternoon, wherever you are in the world. Hope everyone's having a good Wednesday stream. Exciting. Got a triangle up from last time. I guess if you were here Sunday, you'll recognise it. If you weren't, here's a triangle. We've written some code and it renders that. It's pretty great. It's basically a game. So, going to be continuing with the project today. The idea is we're trying to make a simple 3D game from scratch in C++ and OpenGL. And by from scratch, I mean like we're trying to do as much as possible with ourselves. So we've done the windowing, we've resolved the OpenGL functions, we've got some basic OpenGL code, and yeah, we're going to keep going. So I think just before we start, Mr. Bublox raised an interesting suggestion that the last video should be hacking the game that we make, and I think that's absolutely brilliant. Whether it happens or not, I don't know, but I will definitely keep that in mind. John, yes, should it be auto main? Should it use the training return type in the title, as that's kind of the theme of what we've been doing? I think you're absolutely right, but I tried to keep the titles as short as possible, so I'm happy to contradict myself in that respect. Will we use GLM? Oh no, it's nothing but the finest artisanal handcrafted maths classes for us this time. We're going to write our own vector matrix and quaternion class. The only thing I've said that I will cave on and take something off the shelf is for processing like image file formats. I just think spending like 3 or 4 streams writing a ping decoder is not interesting for anyone, and maybe like 3D file format passes as well. Use asimp or something like that. So those are the few things I will concede that I don't think there's any point doing from scratch. But everything else, I think there's a lot to learn. I think there's some fun stuff you can do from looking at your own maths classes and stuff. I will try as we go along to point out like the quote unquote correct way of doing things. In that, when we come to do maths classes, you should probably use GLM, that kind of thing. But here we are. The file standards are massive, and it's just implementing a spec. I don't see there's a huge amount of education about it, because part of this is for fun, and part of this is hopefully to provide a useful resource for people. And again, I think it will turn people off if we're going to spend three streams implementing ping, which means you also have to implement zlib as well. So maybe we'll see what happens. So actually, keep that up. Get used to the triangle, because for today's stream, I suspect by the end of it, we will still just have the triangle, because what I would like to do today is a little bit of refactoring, a little bit of reworking, start building out some of the abstractions, because for me, the API design is actually one of the most interesting parts. API design is incredibly difficult to get right, because you're effectively defining the language that other people will use. We will only be using it ourselves because it's all internal to the game, but actually API design is quite difficult, and I suspect we'll make some mistakes along the way and refactor. So that's what we're going to do today. Let's get to the code. So one thing I want to point out before we start, we got to triangle loss on Sunday. We're going to keep going with it today. We're going to start building out some abstractions today, which I think should be quite fun. One thing I want to point out before we start is Sunday? I made quite a bold claim that C++ doesn't really provide a nice way of declaring thing like one variable in multiple places and then having to define it in a single place. So we have to use this x macro with the do extern thing. Someone quite correctly pointed out that C++ does provide a nice way of doing this. In C++ 17, there's the concept of inline variables, and when you mark a variable as inline, what you're basically saying is to the compiler and to the linker, look, I'm going to define this variable absolutely everywhere. Can you two kind of get together at the end and just make sure only one of them exists, and that all references kind of point to that? So I'm put my hands up, say I missed that. I have not memorized all 2,000 pages of the C++ spec, and doing it live, sometimes when you're coding and talking and sort of flitting between several things, sometimes things escape my mind, so apologies for that. What basically that means is that I should be able to just do this, and then in the Windows one, I should be able to now drop that, and this should still work, and that means it's just slightly less code and slightly more modern. Let's just check that I'm right. boldly claiming that I was wrong and that I'm now right. Nailed it. So yeah, I'm happy to make mistakes and get code reviewed as we go along. I'm still going to keep the X macro because I really don't want to type any of this horror out more than once, so I'm more than happy to just leave it there. So yeah, we'll see what mistakes I make today, basically. It's also easy to forget that's what's commonplace and used everywhere. To one programmer can be exotic to another. Yeah, like, I mean, I've been in C++ for about a decade. Doesn't mean I know every single part or I've used every single part. I'm still learning things. Yeah, CPU reference does have pages for the stuff that's introduced, and I regularly do like check like what's coming up in C++ 23 and 26. But sometimes just things you just kind of forget in the moment that, oh yeah, there's this thing that fixes the particular problem that you're having. So yeah, and also what I realized is my kind of, I guess, not that anyone's seen this, but my usage of Git so far has not been particularly great. At the end of each stream, I've just been like, commit stream 1, stream 2, stream 3, and that's not actually how I use Git. And a few people have sort of said, as we've been going along, oh, it's quite interesting to see how you work through things and your process. So I figured I might as well try and use Git more like I would actually use it. Which would be to actually make small atomic commits as we go along. And then what I'll probably do is I'll tag at the end of each stream the last commit, so if I'm ever looking back, I can kind of see what we were doing. So yeah, that's it. So basically what I would then do is like, use inline for, I don't know, what was it, GL functions. Nailed it, okay. So now that's a bit of admin is out of the way. So what we're doing today. So the plan today is to basically move all of the GL calls out of main into their own primitives. So there'll be a shader primitive, a material primitive, a buffer primitive, an entity primitive. Very loose, kind of define a lot of these as we go along, and we'll probably change them. And the idea is that we should be able to move, and maybe even a renderer primitive, and we should be able to move a lot of this out as we go along. Yeah, and then I want to do some OpenGL debugging, because we haven't really used the debug message control yet, so I want to introduce that. And then if we get a bit of time, a bit of logging, which might not sound interesting, but there's some C++ goodies in there. If you ever looked at your old code and asked why the heck did I do that? Every time. The code I wrote 2 weeks is terrible. The code I wrote yesterday is pretty bad. The code I'm going to write today is the best code I've ever written, because that's how it works. And then tomorrow, which is when today becomes yesterday's code, the cold light of day, it's like, what was I doing? So let's start. So source. So I'm going to kind of go top to bottom for this. The first thing we did is have a shader, like we wrote this compile shader. So I want to move this out into a class, which basically allows me to create 2 shaders, a vertex shader and a fragment shader, and then dependency inject these in. At some point, I'll move these out into files and read them from the file system, but for the moment, I'm probably just going to keep these as hard-coded strings at the top. Just because it's easier. At some point, I think it might be fun to look into like a proper resourcing system, maybe packaging them all up into like a custom binary file, embedding it in the executable so it's all kind of single click and go. There's lots of fun stuff we can do. We're not quite there yet. I aim to just solve like the problems I have now and then worry about the problems I have tomorrow. So let's go for a shader class. So the shader will just represent the abstraction over the OpenGL shader. So it will take a string and compile it into an OpenGL object, manage the handle for it, do the error checking, and then from there we'll have a material class which will just take a number of shaders and then combine those into a program. You can kind of start to see hopefully how we're building this up as we go along. That's the plan. We'll see how we get on. I'm going to want some publics and some privates, and then we're going to include OpenGL, and we're going to include our auto release. and Copilot can go away. I'm not interested in Copilot today. So yeah, you can put your shader code into a file. You can call it .gsl, you can call it .vert, .frag, you can call it whatever you want. The whole idea of like loading resources and interacting with the file system, I'm just not prepared to do yet. Like it's just not what I want to kind of go through today. We will eventually get there to make it a bit more generic, because we're going to want multiple render passes. We're going to want to do things like HDR, and we're going to need to do like gamma correction, and I really want to do obviously do tone mapping as well. I really want to do things like SSAO and a few things like that. So we're going to want a multi-pass render system at some point. So yeah. So we've got this compile shader function we've already written. So this shafer. So we're going to this is basically going to become the constructor. And then we'll manage the auto release internally. What I want to avoid, the whole point in my mind of start again. In my mind, one of the advantages of creating an abstraction is that we can then talk in terms of like the default vocabulary types. So I don't really want to be talking in terms of like GLX. That's an internal implementation detail. So we're going to kind of use our abstraction to kind of hide that away. And also by doing that, we can restrict the OpenGL API bit, because OpenGL has a lot of stuff in it, and this is kind of thinking a bit more like an engine than a game, but it's still kind of useful. We're going to kind of effectively restrict what we can actually do to the bits we need and just extend it as necessary. What's the best way to contact me? YouTube. If you're onto my channel, there's in the About Me section, it has a email address I've created just for people to contact me, so you can contact me through that. That is a-okay. So we're going to have a auto release GLU int handle, and then include string view, which we can use, because even though we're going to pass it to the C API, we can specify the length, so that's pretty good. And then we're going to have an enum class shader type. We could use tag dispatch for this, but I'm just going to create an enum because I think it's useful. And this will have a vertex fragment. Yeah, so I know, you can also pre-compile the shaders by compiling SpearV. When I've done Vulkan before, you have to do that. And actually, when I did it in Vulkan, I drove that through CMake. So I had the shader files in a directory called shaders. And every time I ran CMake, it would pick those up, automatically run through the compiler, and dump them wherever they needed to go. There's a bounty section with an email somewhere. No, YouTube. There's like an About Me section. I think that's what you mean by bounty. Somewhere, I can't remember how the YouTube interface works. I think if you click like channel info or something, it's definitely there because people contact me all the time, which is absolutely fine. It's great talking to people. In fact, the latest video I'm working on has come directly from someone who emailed me about a game they were having issues with. So, I can't promise that for everyone, but this particular puzzle that I was given turned out to be quite interesting. Okay, so one thing I do want to do is, where did we do it? I think it was in exception. Yeah, as we go along, I want to keep the enums printable. It just makes things a lot easier as we go along. So I think I could probably template this further, but for the time being, it's easy just to go just do it as we go along. Shader, and then let's get an exception in here because I'm almost going to need it. Exception. Right, so super quick bit of admin here. Switch obj using enum game shader type case vertex. Bring that up here, bring that up here, bring that up there, move that. Oh no, I still want to return. And then this is going to be the vertex. I don't need the break because it's a return. FV. Do the same for fragment. FV. Fragment. And then in the worst case, we will throw game exception unknown shader type stood to underlying obj. Shouldn't handle be static? Nope, because I'm probably going to want more than one of them. Oh, I never thought about this, but what if you could add a switch statement for vertex fragment shader since you're using an enum class? Yeah, that's what I'll probably do inside the constructor. You'll pass it one of these, and internally it's the shader's responsibility to make sure it creates the right kind of thing. No, there's no default case because if you passed one, that's not expected. I'm going to say I'm going to treat that as an error. Something's probably gone wrong if you're trying to do something that's unsupported. You don't need the breaks when you use return because there's nothing to fall through to. Is there a handy explainer? Is there a handy explainer on making a custom std formatter? I just Google it every time, like how to make a custom formatter, and there's a couple of things on there. Yeah, shader type. Thank you. Good spot. You can probably ask the Oracle. I suspect it will probably know as well. Okay, so we can now go shader, and then we can have std string view source, and then we can have a shader type. Do we need to track the type? I guess we probably should. No reason not to. And then this will be non-copyable by default because this is a non-copyable type, so that's fine. Game. The result. So, can someone explain what the result will be? The result of what? This particular type of code, or the whole project? I'm happy to answer that. I just kind of need a bit of direction on that. And then we can go. Oh, careful. Type const shader type, and then auto. I'm going to call it native handle because this is in line with how other parts of the C++ standard do it, like for instance std thread. So this will be the one time when we pollute the API with non-sort of standard or vocabulary types, because we'll actually at some point someone will use the shader and need to actually get the raw OpenGL handle out of it. So this is their kind of escape hatch to do that. Everything else should be by and large vocabulary types. We're going to try and make a basic, and I say basic in the strictest sense of the word, like it will be very basic 3D game from scratch in C++ and OpenGL, doing as much as we can from possible. And like all projects, it's kind of very easy to start strong and have a great amount of time, and then a few weeks in get bored. So I'm hoping by doing it live, it kind of encourages me to keep up with it. It will not be a AAA, it will not be a AA, it will not be an A, it will be at best be a C game, or a C++ game, I guess, technically. So yeah, next stream I'm hoping to get the cube, but let's keep going with this because there's plenty to unpack today. Yes, source shader.cb, bring that across. Hash include shader namespace game. What's nice is we should be able to just like go through main and replace parts bit by bit and kind of check that the rather than doing it all in one go, we should be able to check the abstractions are working one by one. I'm going to want probably most of these. And then shader. And then from here I'll have our handle will be default initialized, and then our type will be type. Pretty simple. Let's just check this blends. Obviously not. Cannot be formatter game char. Cannot be defined. I'm pretty sure I thought I was being diligent. Nope, I was not. I've had no end of trouble doing custom formatters on this stream. That's fine. I'm reference form parameter. That is a-okay because we will reference that now. Shader. Okay. So what? Sorry. So one thing I've had, one issue I've had with my setup is header file. So I use ClangD, which gives me the autocomplete and the drop down and all that, and it doesn't really like header files because ClangD and NeoVim, they kind of all work off this compile commands JSON file that gets written out by CMake. CMake will write this out, and if you look into it, it has all the files. Basically, it lists all the files that are in your project, and it's like, here's where they are, and here's the flags. So ClangD and NeoVim and all that can basically like, oh, I know how to build this, so I know how to do the correct diagnostics. It doesn't include header files because header files are not compiled; they're not by themselves translation units, and this is kind of like a known limitation with this system. So what I've been doing is using a tool called ComDB, which actually goes through and adds the header files to the compile commands.json. Could not resolve header files. You're right. There you go. So this should, I might need to restart Vim, but this should help pick up those header files. He says, yeah, which then means I can get better diagnostics and notes. It's kind of a bit of an annoyance, like just like a weird quirk of my build setup that I have to do that, but hey ho. Yeah, the extension of header files is largely irrelevant. Your compiler doesn't care. You can make up your own. You can call them whatever. CMake is a bit more opinionated on it. It does prefer that at least your CPP files end in CPP, CC, CXX, and a few others. And then so you've got the parallels with the header files. I'd say it really doesn't matter. I think there's bigger things to argue about over. As long as it's consistent, I'm not that fussed. We're going to main, and then basically going to yoink all this over into our program. Let's minimize that. So now I will need to do namespace auto to native game shader type, and that will be to a GL enum. And it's kind of similar thing we did. In fact, actually, I can probably just copy that from the header file. Because we've obviously got our own abstraction over these types now, but we need to be able to convert those back into the native types. So case vertex, switch type. We will need to return. You know what? I can't remember what they are now. GL vertex shader and GL fragment shader. So if you have both C and C++ files in one project, then you'd want to separate them. Yes, I mean, I guess that is true, but a lot of people will just wrap the C header file, because remember it's just a header file, so those won't actually be compiled, they'll just be included. You can wrap those in as if def C++ and then handle things differently. Yeah, I mean, there's like I try not to sort of evangelize hard and fast rules, because especially with C++, every rule you can come up with is broken somewhere. I can more just like best practices and advice, I guess. So now we can just do to native type. I think this will largely now stay the same. I guess this actually becomes our handle. Take that, take that, take that. Of course now. So I guess we can just do %s shader. Handle. How do I do case insensitive? Case sensitive. Is it backslash? Oh, so I should do confirm. No. Yes. No. Oh yeah. Oh, right. My vim foo has failed me. I'm just going to do it the old-fashioned way. Right, nailed it. No, so I'll also need, I don't need format, but I do need error. No, not error. Why is that source exception? Strange. Oh, there you go. Deduplicated it. Check back when we finish Half-Life 3. I guess someone's got to finish it. So all the other ones I had, it was type and not. I'm a bit of a stickler for consistency, so I do like things to be in the same order. So what I'll just yoink those over, and then we can, because these are all nicely lined up because of the auto word, we can just do shader and bring those in, and then bring those in, do a dot, repeat that, have it formatted, tidy it up, close that. Oh, lots going on. Now, because the auto release primitive we wrote has a casting operator, I should be able to just return handle, and the compiler should just figure it out and return it as the right type. Which is one of the advantages of writing our own one, rather than like abusing unique pointer. Yeah, the other thing is, yeah, you could abstract it yourself. You could have just like a generic integer handle type, and then the callers could cast it. If you wanted to abstract this to support multiple rendering backends, I mean, you probably wouldn't do it in shader because this is quite specific to OpenGL, but if you had like a texture class and you wanted a native handle, then you would have to handle like, what was if I need to return an OpenGL handle or a metal handle or a DirectX handle? The way I've done this before is using std_any, which, has its usages, and I think that might be one of them. You have to be careful. you don't get a heap allocation because you don't really want to be doing heap allocation every time you call native handle. But yeah. What's 5 features of modern C++ you would learn in detail apart from smart pointers and templates? Are templates even modern C++? So templates are pretty old, but they are constantly evolving with the languages, and they are an intrinsic part of the language. So you should definitely learn them. Like, what does it's a really good question. Now I'm actually kind of thinking about it. What would I say to someone who wanted to learn C++? I mean, basic syntax is obviously one, like if statements, classes, switch statements, the actual functions, the mechanics of learning it. I would say your basic data types, vector, map, string, unordered map, deck, any of the containers. Definitely the standard library, which kind of includes those, but then I would extend that. So you want to learn the standard library. So that starts off with, I would start off with the containers, and then I'd move on to the algorithms. Stood sort, stood any of, stood partial sorts, stood max, all those kind of things. So that's, I guess, kind of 3 parts. And then object orientated, because it is useful in C++. So like not just classes, but then inheritance and like what does the virtual keyword do, and pure virtual functions. Then memory management. I would learn what new. Yeah, so stood vector comes under the containers. Like memory management, I would learn what new and delete are, and then never use them, because then it's kind of all this is evolving and building on each other. So learn memory management, and then never use it, and then just use unique pointers or smart pointers, and then you kind of really at that point you have enough grasp to probably figure out what things might be interesting. There's a huge part of C++ for there's a huge concurrency part of it, threads, atomics, condition variables, barriers, latches, semaphores, all those are in the language, so that's kind of fun to look through. Templates, start off with function templates, min, max, why do you need those, and then just kind of build on there. You can go down the template metaprogramming route if you really want to. But yeah, I think that's probably my rough progression of things to learn. Okay, let's see if our abstraction is any good. So we don't want this anymore. That can go. And then we want a auto vertex shader equals game shader vertex shader source game shader type vertex. And then actually, so I guess, because I'm thinking about it in the back of mind, those suggestions I gave there are like the mechanics of C++. Like you say, like the kind of the runes you need to draw in the sand to try and get the compiler to do what you want it to do. After that comes like idioms and best practices, and what does good C++ code look like, and that really just comes from experience and just writing lots of code like RAII and stuff like that. The actual how you apply the key strokes that you write in the best quote unquote way. So it's kind of it's an interesting question. Like, do you start with C, then go on to C++? So I think I really don't like it when people write C/C++. They are 2 totally separate languages. They have totally different ways of writing. They have different idioms and best practices. What is good C is not good C++, and vice versa. They have different ways of doing things. So you might find it difficult to kind of transition from one to the other. What I will say about C, though, is that because it is comparatively quite a simple language, I think if you're interested in learning like low-level details like pointers and like pointers and manual memory management, C is actually a pretty good place to start, because it doesn't have all the extra chuff around C++, which will just confuse you if you're new to it, in all honesty, and kind of get in the way. So I kind of do think there is a progression from C to C++. I just maybe don't really articulate that right now, what that is, but I would definitely say there's no harm in having to play around with C just to kind of get used to some of those more advanced low-level topics in a system that is slightly simpler. Oh, and pointers. I think I should have mentioned pointers. You should probably learn pointers and references somewhere and all that as well. So this now won't work, but this is fine because now we can do native handle and we can do native handle. The only thing that confuses people is double. You learn about it and then only use floats the rest of your life. There's also the ever elusive long double, which no one even talks about in the first place, and certainly no one uses. But there is a third real type as defined by the standard. But most implementations, I think, make long double the same as the double. But anyway, yeah, just to if you want to impress your mate, stand the pub, turn that long double. I'm sure it's long double. He says that now that he's yeah. Fundamental types. Yes, I was right. Float double and the ever elusive long double. So yeah, I mean, there's nothing. I would say there's nothing magic about any of this about C or C++, but C++ just has more abstractions, which I guess can, if you're not familiar with how they work under the hood, can seem a bit like magic. But yeah, C is definitely simpler. I'm keeping people on their toes by having white background when I bring it in, just to check people aren't nodding off in the back. Okay, let's just see if this still works. It does. I will prove it to you. So we've got one abstraction done. And then actually what I normally do is then integrate shader class. Okay, so now the next thing I want is I guess like a material. That's what I'm going to call it. Which will then take your shader types and then compile them up into something that you can use. Why don't I have a dev branch so I don't mess the main branch up? I mean, I can always revert, right? I can always rebase. I can always fix it. So personally, for me, I'm not that a one-man band kind of program. Just one branch is going to be fine. If I want to try something really experimental, I will just create a branch. But I'm kind of happy just to be bold and commit to master. Some people think C++ is incredibly hard to learn. I think it's not much harder than any other language. Obviously, the garbage collecting is different. I just think there's just a lot of nuance to C++ which people aren't expecting, like especially coming from other languages. Like undefined behavior is obviously a massive part of C++. The whole thing is just like a bear trap waiting to happen. And in the worst case, it looks fine and it runs fine until one day it doesn't, and then you'll be like, oh, it was undefined behavior. You know, your whole program was undefined, and you just got lucky, or I guess technically unlucky until now. I think there's just a lot of stuff like that. There's a lot of things that are not necessarily intuitive, or are intuitive, but kind of you have to take the time to get to that intuition. So we're going to now have a class for the material. This is going to look, no, we're not. This is going to look very similar to our shader class. And so we're going to have public, and then we're going to have private, and then we're going to have OpenGL, and then we're going to have our auto release. If you wanted to break the dependency on OpenGL, so you didn't want, because OpenGL now effectively has polluted this class everywhere, including material H. I'm effectively transitively including OpenGL. You could use something like the Pimple idiom or something like that, or inheritance to kind of really abstract it. But for this, where we're really probably only going to be supporting OpenGL, at least to start with, that's what I really care about. So, and then look, there's kind of best practice. I think someone's really touched on a point here. It's like, it's even kind of hard to know what best practices are in any language, especially C++, because you look at it and you think, oh, like shared pointer is such a great example because it's like, oh, it handles all my references for me, you know, reference counters, I can copy it around. Other languages use reference counting, it's pretty great. And then actually the advice really is shared pointer is almost never the right answer, because if you think about it hard enough, you probably have like a memory hierarchy and you can better handle your memory dependencies more explicitly, and then you don't have to pay the overhead of an atomic increment or decrement every time you sort of throw this shared pointer around, because ideally you create a unique pointer and then just hand out raw pointers to people if they don't need to take ownership. So yeah, like you know, it's, but at the end of the day, like if you write a shared pointer and it works and you deliver value from having written that code, then who's to say that's right or wrong? So what is GL create program returning these days? GL uint handle, and then as before, auto handle const GL uint, and then we are going to take, I'm going to hard code the material to just take two shaders to start with, the vertex and the fragment one. If in future we want to have more shaders, like if we want to have a compute shader or a geometry shader or whatever, then we can make this a little bit more generic and take like a collection of them and build them up. But for now, like, let's just keep things simple. So we're going to have a const shader vertex shader and a const shader reference fragment shader. And again, I don't need to take ownership of these, because I'm just going to compile it all into a handle. I can just have these passed to me by reference for the constructor, then I don't have to worry about them afterwards. And again, this won't be a copyable class, so I don't have to worry about that. So yeah, share pointer, I think the real use case for share pointer is between threads, when it's very hard through just like especially if your threads are kind of spinning up and tearing down, and it's kind of slightly non-deterministic, and you don't know who is going to be the last one out to switch the lights off, then that's, I think for me, that is the use case of shared pointer. VS source material.cpp is not what I wanted. I've now got a file called VS. What have I done? Right, let's try it again. CP, and then I can take my material header file, put that over there, and then hash include a material namespace game. Pretty gross, but just gonna copy these over, copy over my headers, and then close this down. Material, and then material on a bang, and then yes, you're correct. Share pointer, I think I'm maybe coming into the conversation here where you've kind of arrived at the salient point, but share pointer does not provide you mutual access over the object that it is managing. Just the internal bookkeeping part is thread safe because it uses atomics. yeah, it uses atomics under the hood. There is no locking. It's it could consider it lock free, or at least I mean, unless your particular implementation has to implement atomics with full barriers, but it's very unlikely on a modern platform. They'll almost certainly have atomic instructions, so you can that's the key point. It doesn't give you mutual access to the thing on the other end of the pointer. And then handle default initialize that. Handle. I want to call that native handle. If I call it that in material, not native. Blah, blah, blah. All right. Okay. Now we can go back to main, and then we can just. That's the whole point of this abstraction. Is I'm literally lifting and shifting the code I've already written. And then put it into an abstraction, a class. So I'll take all of that gubbins, not stick it in there. It's not where it goes at all. Everything I was working on has just disappeared from underneath my feet. Thank you. Right. And then I want hash include error. So the goal of today's stream is to just do a bit of refactoring. We want to, well, not necessarily refactoring, is to start building out our OpenGL abstractions. So we are, using the like the low-level functions, like not directly, they're kind of going through an abstraction we control. I also want to do some error handling and some logging if we get time, because there's some interesting stuff you can do with sort of templates and stuff around logging, which I think people who are interested in learning more about templates might provide some interesting insights. So what are we doing? So I was just thinking about this in my head. We could ensure or assert that this is indeed a vertex shader and fragment shader by checking the type, but I'm pretty sure. Would this fail? Oh, no, it's just attaching shader. Okay, fine. So we should probably like verify our preconditions. Shader dot type equals shader type vertex, and then be like, shader is not a vertex, a vertex shader. One might argue that this is widening the contract a bit, and like we've stated this as a precondition of the function that you should pass these in, so why check it? This here is an excellent use case for asserts, but I've not written like an assert yet, so I'm just going to keep it as this. Please pass me the data that I've asked you to pass me in order for me to meet my post conditions. There's a whole philosophy on like wide and narrow contracts and whether you should even do something like this. I've chosen to do it for now, just as we're getting started. What I might do in the future is when I eventually have to write an expect, which will be like our version of an assert, come back and replace that, and then they get stripped out and debug. But just a bit of, I guess, like error handling philosophy for you. Material. Yep, there'll be gamma correction because I also want to do HDR and tone mapping. So we'll get to that. That'll be. I imagine I'll probably do that as one final render pass. Native handle must return a value. You're probably right. It probably should. Thanks, compiler. What's my thoughts on Visual Studio Code versus Visual Studio? I used to use Visual Studio pretty religiously, sort of 5 or so years, more than that now, 6-7 years ago. It's great, like it's a big bit of software, but it's got a load of great tooling, it's got a load of debugging stuff, it's pretty good. I switched to VS Code just because it's a little bit more lightweight and cross-platform, so it's more useful for me doing Linux stuff. And I found that the Vim bindings were about 80-90% of what I wanted. So I think they're both great. A tool is a tool. You pick whatever works for you and whatever helps you get the job done. I maintain minimal opinion over like what is right and what is wrong when it comes to tooling. I don't know why. There you go. Fix it. Do I make use of Microsoft GSL? No, because again, I'm trying to build as much stuff from scratch as possible. Yeah, so this is I'm influenced by GSL because I've written Ensure, and it also helps because it works with my own types and it throws an exception, which is what I wanted to do. I might use not null. I've been thinking about this. We might need a not null at some point, but again, I think part of this project is it's a good excuse to kind of build some stuff from scratch to see how it works. So we might like build like not null and stuff like that for ourselves. Shouldn't you check inside the function if the attach was success or not? So GL attach shader, I believe, is void. It doesn't return anything. What will happen is you would. We were discussing this last time. You were traditionally called like GL get error after each of these, but it's kind of legacy and it doesn't. My understanding is it doesn't catch everything. We're going to set up later. It's almost like the debug, kind of like the debug layer in Vulkan. We're going to set up a debug function callback, which we will then instruct OpenGL to call for us after every single function, and then that will give us information about whether everything failed, and then we'll use that to do the error handling. It kind of means that we can kind of defer the error handling to OpenGL for us. So we just call OpenGL functions, and then it will kind of go tell us via this callback whether something bad happened. So get integer for compile. Yes, so the compiler, didn't we do that in the shader? So shaders have this explicit extra step they have to do, which is kind of unlike a lot of the other primitives in OpenGL. It is what it is. Yeah, we're going to throw it. We'll throw an exception. I like exceptions. All right, another sometimes contentious point, which I think is kind of interesting. Material, and now we can get rid of. Oh, I've already got rid of it. That's useful. Auto. Did I not have? Where's? Okay, fine. Auto material equals game material, and then this will take the vertex shader and fragment shader, and then in here we can just do material dot native handle. I've been doing graphics programming like on and off since university, which is many years ago. What does my thing say? I graduated in 2013, so I've always been interested in it. In fact, I took took one or two modules at university on graphics programming, like a ray tracer and stuff like that. So I've always been interested in it. I've just never done it professionally. So I kind of this is just stuff I've sort of picked up along the way. Sorry, lots of questions coming in. I am trying to keep up with the chat as I go along in programming. If I miss your question, I do apologise. As a little bit of a plug, I do always respond to super chats, but that is kind of up to you whether that is your thing or not. It's absolutely not a requirement for me. Answering questions, brilliant. Triangle has gone. Clearly made a mistake somewhere. What has gone on there? Do I have to buy? No. What have I? Yes. What? I've just moved code from one place to another. Like I'm pretty sure I've introduced very few changes. Very few changes indeed. Oh, I've just stored it in a local variable, then immediately released it, haven't I? Now I can do Vim magic. What a fool. GL delete. Ah, oh, it's the same thing because I've chosen a. No, no. Yes. No. Yes, yes. No, yes. Yes, we'll be logging soon. Nailed it. Brought it back from the brink. Don't worry, guys. This will also be this will not be the first time that we just get a blank screen and despair at it. So, right, so what have I done? I've added a material class, so add material class, and then I've integrated material class. Right. Don't worry. We've committed it. It is committed. It is written into the ref log for time immemorial. There is no way we're losing that. I guess so. Now I'm going to need a buffer, and then a way to write into that buffer, and then a VAO. I haven't really thought too much about how I'm going to abstract this yet, because VAO is probably going to be very similar for most entities, I guess, because I'm planning basically on having a pretty fixed vertex data for everything, at least until we need it to be more specific. I know you can, using the DSA, have different buffers bound to different ports, so you could have just like the position data and that, but I want to keep them interleaved as much as possible. So what is going to happen here? So I use lazy git from as a command line git utility, and then I've just edited my I've just got the lazy git NeoVim plugin bound to space LG, so it just brings it up. But yeah, lazy git is the underlying tool. But yeah, it integrates into NeoVim, or at least I have an integration of it into NeoVim, just so it just pops up over the top, which is quite nice. So it is kind of a Vim extension and not at the same time, if that makes sense. You have to have lazy git already installed. Do I just... What did I do before when I did this? Let me have a quick look. Where have I called GL vertex attrib pointer? Like I said, I don't have all the answers straight away. I'm figuring out a lot of this as I go along. GL enable vertex attrib array. Apparently I never used these functions before. What the header file? What have I got in my header files? Render target, renderer, sample, shader, uniform, mesh. VAO goes in the mesh. Okay, fine. So I'm going to do that to start with, because that's what I've done before. So I have a mesh class. The mesh will contain the data and the VAO, and I guess from that it will create the buffer. Is that what I want to do? I'm fully prepared to make mistakes in the abstraction and refactor it later. Let's just wrap it all up into one class, keep it all nice and tidy there, and then we'll just redo it as we need to. Source mesh.h. And then graphics mesh. I don't have all the answers. I'll clip that into a short. Obviously not what I wanted. Obviously. Right, so going to want some publics, going to want some privates, and then we're going to want to start thinking about what we're going to do. So, I'm going to want the VAO and the VBO and the data. I will probably just upload the data directly to the VBO and make it static, effectively kind of like static to start with, and then in future we can kind of extend it. I think that makes sense. Let's do that. Otherwise, we'll spend all day in analysis paralysis, and then another hour will go past, and we've achieved nothing, which is not what I want to do, because I want to do some of the error handling and logging stuff today as well. So I'm just going to create. Actually, let's leave it. Let's have a mesh. Whoa. Steady. Right, okay, Vim. Don't hurt yourself. We're just going to have a mesh class which just renders our triangle at the moment. So, and it won't really have the ability to kind of render multiple ones or anything like that. It won't have any sense of position. It's just going to encapsulate all this, and then we'll expand that as we go forward. So, what do I want? I want a is it GL gen buffer? That sounds like a thing I want, at least for the moment, because again, another one of the things I want to do is, after we've got the abstraction built, is go back and modernize some of the OpenGL. There's some more modern constructs we can use. So yeah, let's just start writing some code. GL uint VAO, and then we're going to go with VBO. I think that's what we need to start with, because I don't have a separate index buffer. I don't have anything like that. Yeah, and then to draw it, not using auto. You can't use auto for member types. I don't think you can. My GitHub username is Nathan Baggs. It will be posted somewhere. Because I don't want the mesh to have a draw method, because I don't think it is the responsibility of the mesh to do the drawing. It will be the responsibility of the renderer to do it. So I guess that is just going to. So that when we get to it, that will need to know. This will just need to be able to bind. So let's do auto bind const void. Let's start off this way. I suspect we will change it, but because it's a state machine, let's kind of work with what we've got for the moment. And yeah, we'll see where we get on. So I will actually need a constructor. It won't take any arguments, because this is just going to be, like I said, keep it simple. This is just, we could have just named this like triangle, but we'll just refactor it later. Okay, right. I've waffled, and I've not rewritten a lot of code. So, you know, what's new? Namespace game, and then we've got mesh over mesh, and then we had auto mesh bind const void, and then fbind unbind, and then this is the definition. Let's go open up our CMake file, add that. I'm a stickler for keeping these in alphabetical order. I know it is in alphabetical order, but if you do Control V to select rows and then shift colon sort, it will sort them for you, which is quite nice. Mesh. Do need that debug callback. It's coming soon. Soon, TM. Soon. I probably should have done that first. Like, should have had the debugging. Oh, this repo's not public yet. I've undecided whether I'm going to make this public or not, because I think it would be quite cool if we actually made a game to actually try and maybe list it somewhere like Steam. If it's looking like that is a fantasy that is unlikely to reify, then I will release it later. So I'll keep the code reasonably good quality and tidied up, and then maybe at some point in the future I'll release it, or I'll fork it and just release some of it. I haven't decided yet. I'm undecided. This means you have to watch the stream. If you're interested in a bit of code, you'll just have to watch the streams again, I'm afraid. Okay. Let's update my whatever it is, DB nonsense. Did that build? It did build. I suppose I'd be a bit worried if it didn't. Let's grab all this nonsense up to 98, bring that across. I will also need, excuse me, my OpenGL and my auto release. I know they're included from the header file, but I like to include the things that I need at the point I need them, rather than relying on transitive includes, which is always a recipe for disaster. And then we can go EAEIO, and then VBO EIEIO, and then these are that. Okay, so we're going to take a local VAO, and then we will, because this annoyingly writes to a point, sets this via a pointer. If that makes sense. Right, okay. So this function here goes gen vertex arrays. It will generate the primitive that we want, and it will stick it into this via a pointer. I cannot put that straight into the auto release because doing address of auto release doesn't work. We could write an address of operator for auto release, which does that. Do we want to do that? It's kind of a bit hairy, but it might work. You're not really supposed to overload the address of operator, but I've done it before. Let me see if I can find it. Where have I done this before? Okay. Let's just see if this will work. It's a little bit terrifying. But we could do T star operator address of operator, no except return third address of obj. So basically what this will do is when we take the address of our auto release, it'll actually return the address of the thing that's internally. Which, yes, of course, if you use then the point of stood address of is then it will do the right thing even if the address of operator is overloaded. That is correct, yeah. So in theory here I should now be able to do that, and it should work. I think I'll have to give it an initial value and the destructor though, so I think I'll have to give it U and GL delete buffer, which I've got a feeling we might not have defined yet. We've not. Exciting. GL gen vertex array. Is it GL delete vertex arrays? So GL delete vertex arrays. GL gen vertex arrays. GL CTV delete, and then GL whatever puffin GL and gen whatever it is. delete. So that should work, I think. Is that going to work? You'd rather use a reset method, but then a reset method still has the same issue, right? Is I can't use the function I've already been given to write directly into it. I'd have to put it into a temporary and then put it in. It's not the end of the world. Again, this is more of just showing people like what can be done. He says what can be done. I haven't actually checked if it works yet. Lots of errors. Let's see if we can fix some of those. Yeah, by the way, it's one of those things where just because you can doesn't mean you should, but I have. I don't know what I've done wrong here, because this should match this constructor. GL delete vertex arrays. It's because it takes two arguments. It takes the auto VAO, and then has to pass in one ampersand VAO. I think that's right. Why put that in an anonymous namespace? I just feel it keeps this code a little bit tidier, right? And now I can just kind of look at the OpenGL functions. Eventually this is going to disappear and we're going to dependency inject this. So you can put it pretty much wherever you want. I just wanted to keep it kind of out of the way. So when I'm looking at the OpenGL code, I don't have this horribly, terribly formatted list of numbers, which I'm sure must be a better way of formatting. But I don't know at the time, so. Yeah, so this is an anonymous namespace. It restricts this entirely just to this translation unit, so vertex data doesn't leak out. No one else can extern vertex data and get access to it, if that makes sense. I'm not, yeah, so, oh yeah, I see what you mean, sorry, I understand, yeah. So this is what's called an anonymous namespace. It basically means within the CPP file, only the CPP file can see this, and no one else can, the linker can't accidentally patch this through to someone else, wire this up to someone else. I guess static does have the same implication with the linkage. I am out of habit just put everything in at the top of it in an anonymous namespace. That is more of a habit of mine. So yeah, you can kind of do it either way. I do try and separate my own kind of idiosyncrasies from maybe like this best practices or whatever. For me, like if I'm doing anything that I want restricted, it goes in an anonymous namespace. If it's called, I just copy and paste it because it was static elsewhere. There's no need to probably do both of these. That's my reasoning for it. Again, I have precisely zero emotional attachment to this code because it's going to go away probably next stream. It's just there just to kind of get us going. And now I can do the same for VBO. So 0U auto VBO, and this will be GL delete buffers, GL delete buffers 1 VBO. Careful. And now I need to go to OpenGL. Where's our gen buffers? Here it is. This is the nice thing about this X macro though, it does make this super easy to do. So I'm kind of glad we've kept it in, even though I hate macros. This might be one of the few use cases for it. Mesh? Were we meshing? I think we were. I think we were meshing. And then this becomes that. And again, because I've overloaded the casting operator, I can just pass my auto release object into all these C functions, and it just does the right thing. So there is, yeah, hopefully some method in my madness. Again, like this is all hard coded. This is absolutely fine. We're going to figure this out later. Just want to write to this data, and then we should be able to just do bind and bind. We could, and I have done it before, line 40 needs a VBO, line 40 needs a VBO. I've just moved all the code around, so... Yes, you're right, it does. Thank you, thank you. Good spot. I have written before like an auto bind, which is an RAI class, which on the constructor calls bind, and then on the destructor calls unbind, just so you don't even have to worry about that. I think for this, we probably don't need it at the moment, because again, when we design like a proper rendering class with like a pipeline, this all might change anyway. This is literally just to start building out an abstraction for us. So now, well, actually, let's just check that. Let's check that blends. It does not. Local variables. If I still, oh yeah, he's not wrong. Compiler only occasionally is wrong. I'm hoping 3D. It is. I mean, it's OpenGL. Technically, everything is 3D, but it's going to be 3D hopefully. It'll at least have a cube, is what I'm going to say. At least have a cube. Right, so now I've got mesh. So now I can do auto mesh equals game mesh. And then we can do clear, use the program, mesh.bind, mesh.unbind. This is kind of all there is to it. Nailed it. We hath abstracted. Yeah, I mean, we're going to get to Z buffering later, blah, blah, blah. I'd quite like to do like maybe like a Z buffer pre-pass, because I don't think I've ever really played around with that before. It's kind of cheap and easy to do, so it might be fun to kind of, again, I want to build out a pipeline, you know, it has multiple rendering stages. It is that time of the evening where we must commit our code. So add address of overload. And then we commit, add, delete OpenGL functions, mesh, and then cmake commit, add mesh class, and then commit integrate mesh class. Nailed it. Okay. I said we're going to try and get rid of all the OpenGL functions. We've not quite. There's still some here. We still need to build out probably like a renderer and stuff like that, which will, you know, do the clearing, do the swapping. But I'm just looking at the time. I try to stream for 2 hours. We've got 40 minutes left. So I'm trying to think whether I want to do that or I want to start looking at some of the other bits and pieces like the error handling and the logging. We could build out. Let's quickly build out a renderer class. I think that's what I want to do. source renderer. No, we're not going to use Abstraction Logging. We're going to write our own one, obviously, because there's some interesting stuff around it. And again, like I pick the stuff to do ourselves from scratch, where I think there is, I think it's pretty stuff. I think there's value in kind of doing it as an educational resource. Mook Steve. I think you're right, Mook Steve or MC Steve. This is okay, so I'm going to assume it's MC Steve, but unfortunately now you are forever Mook Steve. It won't take 2 seconds. But then I want to write like a logging function after that. I prefer Pragma once over header guards. I've never heard any advice that says to use both. So yeah, but I prefer Pragma once. It's one of the few it's probably the only non-standard bit of C++ I will use because it's not technically standardized, but all the compilers have kind of got together and say it should do what you expect it to do. So, and I find it's less error prone because you will almost if you have header guards, you will almost inevitably end up copying and pasting them from another file and then forgetting to change the wording in them, and then weird things will happen. Let's go. Eventually, the renderer we will be able to add and remove meshes from. So it'll have like a names are important, and I always try and call people by how they would prefer to be called. So Steve, if you're happy with Steve, I'll say Steve. Eventually, the renderer class will want to add and remove entities too. This will probably we'll probably create a scene object and then add that and then hand that over to the renderer. So I just think for a moment we're just going to have like a render method, and then this will have our mesh.hin. And then this will have our mesh. Again, this will eventually have a scene object, I imagine. Oh, so much to do. Just so much to do. So little time. Probably a puzzle game, I imagine. Something simple. I'm thinking like literally rendering cubes that kind of move around with some mechanics, and you have to kind of maybe get into the right slots. That kind of level of like in-depth game design. What am I doing with my life? Right, okay. Renderer.cp, swap those around. Include every time. Renderer.h. A lot of typing out namespace today. It's been a namespace heavy day. Renderer. I don't even need a constructor. Rule of 0. I think everything will be default constructed how I want it to do. So I think I just need auto render const or void. I think. Yeah, sounds good. Could even be right. Could even be right. That's not right. That's absolutely not right. MNOP render CP. I think you'd probably only have one renderer. Like that would be the idea. Like, you know what I mean? You create the renderer at the start of the game, and then you just add and remove stuff from that, and then there's every tick. It does render things. Render. Just update my thing. I should really have that done on like a CMake post build step. Update my compile commands. Main. I actually have record scratch changed my mind. I do want a renderer constructor, the default one. Well, one that takes no arguments. And I'll tell you for why. Renderer. Alright, and now we get a main. He says, not going to main. I can set the clear color. When we eventually write our own color class, because obviously we're going to write our own color class, then we can have render maybe take the clear color or have it set. And then on render, we can just do 69, put that in. This will now steady. Oh, that's going to need a material as well. Interesting, because we're not going to. Where would the material go? I guess that would be intrinsically. We would have probably an entity class which would own a mesh and a material. Again, for ease of use for this, we'll just have the render everything, and it can only render one thing anyway with a material. So let's do material. It's funny how you kind of think, oh, just this be simple, and then actually, even with like basically nothing, the complexity starts adding up, and like how all the parts like interleave with each other starts coming out. That's why interface design is so difficult. I access the free functions via the global namespace, because to me, as a convention, it signifies that I didn't write that function. That's why I use it. So when I'm scanning down here, like I know, oh, this is not a function I've written because I've accessed it from the global namespace. It also instantly kicks off the autocomplete as well. Or, you know, it would if I had a better example. Include material underscore std move material. Because it's non-copyable, we'll have to effectively take ownership of that. That's fine. We can move that in, and then make handle, and then mesh.bind, and then we're going to take the swapping buffers out of the window, because I think that is the renderer can do that. I'll go hash include windows.h, that there. Nope, it can't because it has to have the DC, obviously. Fine, we'll keep that as part of the window. That's annoying. Why don't I pass a material ref? Because, well, this is kind of an interesting part of API design, right? By passing something in by rvalue reference, I'm effectively saying to the caller, I am taking ownership. Well, you should transfer ownership to me, but I kind of give. What am I trying to say? There is a reason. I think this is clearer because this basically says I want my own material. It also means I cannot pass in a L value if you take it by ref. I think. So by here, it's semantically it's very similar. Whether I take this by value or ref because it's a non-copyable type, someone will have to std move it into me. I feel like taking it by value. One, it's kind of clearer and it's less typing. Also, I think you can't. I'd have to double check this because it's one of those weird edge cases. But I think if you take it by ref, you can't pass in a temporary. I think. No, that would make sense. You can't pass in a. I'd have to check. There's a semantic difference between doing it. Yeah, that's it. You can only pass in an R value. Yeah, of course, because you're saying this has to be an R value. You can then only pass in an R value. Whereas I can then construct this in place, and then it kind of the language just sort of picks it up. Yeah, I think that's a good way of looking at it. So passing by value is I want my own copy. Passing by ref means I want to take your thing. I don't actually care. You have to remember that. I don't care semantically about whether I've taken ownership or of someone else's. I want a material to render with, and it's non-copyable. So I have to, because I need to effectively store it internally, I can either pass it by ref or by value, and I personally prefer passing by value in this case. Caught me off guard there. Good question. I hope I gave a satisfactory answer. If not, I'll think about it and get back to you, because I'm pretty sure that's the reason for it. But this is the joy of doing things live when you get a question you weren't expecting. You've got to think on your feet. So I don't need the material anymore. What I do need is auto renderer equals game renderer, and then stood move in the material. I think as well these can be const, and then in window I can now do renderer.render and window.swap, which means I have now moved out all the OpenGL code. Boom. Renderer. Oh, I haven't even thought about font rendering yet. What an absolute nightmare. What an absolute hot mess that is. We'll probably give it a go doing it from scratch, because who doesn't want to write their own rendering glyph formatting nonsense? Alright, okay, so what have I done? Add renderer class, and then steady. Integrate renderer class. Okay, cool. So Windows, I've done this before, and Windows does have its own using, I think, is it direct text? One of the direct APIs does allow you to do font rendering. Even though we're using OpenGL, you can still use that API. So that's what I've done before. So I might give it a go, because it is horrific, and I don't know, it might be fun. Oh, I mean, if we can't render emojis, then what is even the point? I'm quite pleased with that. I think for, you know, let's we'll amend that, because it's part of the integration. Sure, quite pleased with that. It's not too much code. I mean, obviously, it's a lot of the abstractions behind the hood, but it's looking pretty good. Now let's have a look at error handling. Where's that going to go? I suspect it might go in the window class, because we probably need to do this like pretty soon. As soon as we set up OpenGL, we want to be able to get like logging from it. So let's try that. I'm just looking up, double checking what I need to do. So we need to GL enable it, and then we need to do a GL debug message callback, and then the message callback signature is, it's going to be blinding white. This here. Oh, it's actually got a type def for us. That's interesting. Thank you very much for the membership gift. Very kind of you. What am I doing? Sorry, got distracted. Let's do, as we've kind of broken this down into functions anyway, and they'll see functions, doesn't really matter. We'll do like setup debug. Because again, on like a release build, we can then not do that. So, careful what I say that. Debugging to file, not debugging. Debugging to file or console. Again, I'm just solving the problems I need to solve right now. So we're just going to debug to console, and then we can extend it to file as we need to. Because I imagine if I ever needed to get someone else to play this, debugging to like logging to a file, it's going to be useful. Again, let's just solve one problem at a time. So GL enable, and I need to GL enable nope. It's one thing annoying about NeoVim, I must figure out if I can change it. When I delete something, it puts it in the paste buffer. So I copy and paste something, I go over here, I delete the thing I want to replace, and then I've lost it. And then I'm going to want my debug function, which suggested debug. Debug. No, okay, fine. I'm just gonna take the signature here. Auto debug. Let's call it what? OpenGL debug callback. Void. Yeah. Okay. Just that's not what I wanted. That's what I wanted. All right. And then just to keep everything happy, maybe unused. It's impossible to say. No one really knows. Yeah, so I will almost certainly have a logging. I will extend the logging system at some point to have multiple syncs. So at the moment we'll just have a single sync, which is the terminal, and then we can just have a vector of those, and it will just loop through them all, and maybe multiple formatters. I don't want to spend too much time writing a logger, because whilst it might be fun, it doesn't really get as much closer to making a game, and that's kind of what I'm doing. But I think there's some interesting things to do. I think the API entry is what I need. Good point. Who knows what calling convention it uses under the hood? What horror? Could be Farcical. Unlikely. It's a C function, but you never know. Okay, so what have we actually got here? Let's register it and stick a log in it, and we'll just print everything out, and we'll see what we get. GL debug message callback. OpenGL debug callback. Nope. Nice try. Null pointer. So kind of classic C API. It allows you to pass in like arbitrary user data as a void pointer. I'm not going to do that, at least not for now. Oh my goodness, what is going on? Right, okay, so now I need, what was this called? Let's see if I can get this right in one go. GL debug message callback proc. It's even there. So GL debug message callback. Okay. Again, like I've never used Emacs. A lot of people do, and they write code and they produce value. So as a tool, it clearly works. So fine by me. People should use whatever they're comfortable with. Obviously, it's kind of fun to have a preference and to discuss it and stuff. But I try not to be too evangelical about any of the choices I've made, because I imagine most of them are wrong. So we still got print installed, so std println source type ID severity length message source type ID severity length message. Suddenly got something. Okay, I assume that's what. I mean, buffer detail, buffer object bound to GL array, usage hint is just always use video memory. Sounds great to me. Can I not do that? Can I force an OpenGL error somewhere? What's going to be OpenGL error? Not the shader, because that is reported separately. I want to pass like an invalid handle to something. I guess like bind. If I just pass in like 99999 here. Oh yeah, certainly doesn't like that. Nice. Okay, right. So we can definitely get some error information out of it, and I guess that probably comes via the severity of it. So the source is, in fact, I'll just pull up the kind of guide I've been using. Don't worry, this isn't blinding white. You got the source, which is where it comes from. So it either comes from the API, the Windows system, the shader compiler, blah 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 blah. You got the type, error, blah blah blah, and you got the severity. So I find it interesting. I'm sure there's a reason for it. I'm sure it makes sense. But the fact that you have error and then a severity, because error sounds to me like a level of severity. Does this mean I can have like a low severity error, or is error always high? I don't know. Kind of interesting. That's just where what I think of when I see that. I want to. I've got a bit of time left. So but what I'm saying is like error sounds to me like a severity. Like maybe, but maybe who knows, right? Anyway, that's really not the point. So what I want to do, I want a super simple logging system. I want to basically have, in my mind, you don't want too many log levels, because then it kind of gets confusing what you should use for what, and you end up kind of mixing and matching them, blah 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 blah. In my mind, there really is like 4 error levels. You've got like error, something has gone wrong, I am not continuing, fix this now. You got warning, which is like something has gone wrong, I've managed to continue but maybe not quite in the way you think, or like it might have a degraded experience, you should definitely look into this. Yeah, and then info, which is like trace, I guess, like here's just things you might be interested in. This kind of helps you understand the flow of the program. And then debug, and debug is just there to kind of stand out in the log, but you probably wouldn't commit it, it's just there for debugging. I kind of like to have that as a separate one. So really there's sort of like stuff that's happened, stuff that might go wrong, and stuff that has definitely gone wrong. It's kind of like 1,000,001 ways of doing this. What I really want to leverage though is print and format, because I just think they're such an amazing addition to the language, right? Yeah, debug omitted in release builds as well. There's that as well. So what I really want to do is something like, I don't know, kind of figuring some of this out as I go along. Namespace log. Right, and then have something like auto info, which takes a std string view and then some number of args, and then template class args args and we could do this now, right? Because we've done something similar before. This would work. But what we really want is source information. Like we want like the line, the function name, the line number, all that sort of stuff. And traditionally you would use the macros for this, but since C++23, we have, you know what, I'll put the read mode on. We have std source location. So this allows you to capture things like, oh, I do not care for this, I'm turning this off, sorry. Line, column, file name, function name. Okay, pretty cool. So we're going to use we don't want to use macros, we want to use the mod stuff. Now, the way you use this is include source location. Std lock equals std source location. Now, this will not work. Yeah, we could use format string there to keep it context bro. So we can use formats that leave format. I'm kind of just going through the mechanics. We'll tidy it up as we go along, but that's a good point. This will not work because of stored source location current. Because we kind of end up with a clashing almost of mechanics here. The variadic template arguments tend to want to be the last in your arguments, so it can deduce them. It doesn't always have to be the case. And default arguments definitely have to be the last arguments. So this won't actually, I strongly suspect this won't actually work. Let's just try it. Oh goodness. So let's just try here. Game log info. One. Yeah, cannot convert argument one to int. What this is basically trying to do is it's trying to map. This is deducing template arguments. So this has deduced a single template argument of 1, but it's basically the way the language works when you do it in this case. It's going to say, here's 0 more template arguments. Oh, and the last one's always this. So it's going to try and convert your 1 to this, to a source location, which obviously won't work. Those are incompatible types, right? I believe if you force this and say, no, I want 1 template argument with a default on the end, this will work. Yeah, undefined reference, doesn't matter. Right. But obviously the whole point of this is I want to be able to pass a string and then n number of arguments that will get formatted with these curly braces, and I don't want to have to specify them every single time. So we're kind of almost at an impasse. All right. Is, well, the language will not let me do this. I cannot deduce these arguments into a separate list and not have this try and effectively capture the last one. But, well, you can't do it with functions. But let's go log. Let's call this, keep it generic for the moment. I know we've got log. Don't worry about that. Template class args. And then in here we have a stud string view. Actually, let's get rid of the first type. Let's get rid of the string view to start with. Let's keep it simple because it still won't work, right? We're going to have args args stud lock equals stud source location current. Okay. Why is it not like that? I literally just... Oh. Okay. Yeah, okay, fine. Okay. So this still won't work because we still should have, in theory, we should still have exactly the same problem. Is lock is not understood. I'm surprised. Ah, stud source location equals back here. There you go. Right. So this should still be the same issue, is that it won't be able to convert, cannot convert into stud source location. But what we can do is use something called a deduction guide. So we can basically say template class ... args log args ... becomes log args ... So log is a bit weird, so we'll just we'll change it in a minute to maybe something like print. Let's see if that works. So that works. Again, it's just because this is give it that. So what this does is this is called a deduction guide. So this allows you to tell the compiler how it should do deductions. So what this basically says is when you the compiler have deduced a variable number of arguments, please make sure that those become the template arguments. So what this does is this will say, oh, I've deduced one template argument as an int. It will then see the deduction guide, make sure those end up in the args, which then leaves you free to have a defaulted one at the end. So it's kind of like a little bit of a trick, but you can only use deduction guides with structs. So it's a little bit of a pain that we have to go via struct, because this means it technically will create an object, but I'm not that fussed about it. What we're going to do is start tidying this up. So this is going to be like our basic like log print function. This is going to be like the raw print. So let's do stud print ln, and in here we're going to have, let's just do file. I want the file name, and let's just do file name and line number first. So this will be lock dot file name and lock dot line. YLN, just do print and \n. It's less typing. I would argue it's semantically clearer. Where have I gone wrong? I sort of didn't finish my sort of mini refactor. Let's just bring that in as well. Hopefully keep the tooling happy. The final one treated as an error, unreferenced formal parameter. Is that this one? Yeah, okay, fine. Let's just delete that for the moment. Bring it back in a minute. So we can see here that we've got our file. I mean, it's the full file name. We can and the file number. So we can now successfully capture the source code line information, and now we can start adding in our own parameters. So what we want is the first argument to be, and I think here, so basically what I want to be able to do is like my arg, right? We're going to need the first argument to be effectively a C string, and I think it has to be a C string because of the way that, because this will always, whatever this deduces, we will always want to kind of capture that and make sure that it is that first type. So what I'm saying is like args is going to be char star and an integer. I need to kind of peel off that first one and then stuff it into a V format and then pass the rest along as arguments. So again, what we can kind of do now is do a bit of template specialization to capture that. So let's default that as that, and then bring this down here, and then we'll do struct print const char star args ... So this is just template metaprogramming. It's just pattern matching, right? It basically says we're going to expect to struct with a variable number of arguments, but we want to specialize the case when the first one is a const char star. So now what we should be able to do is have our error message, which will be std v format. Because now I can capture this here. Const char. I don't think this will work with string view or format string, like someone said, because it won't do the implicit conversion. It will just forward this. It will just deduce this type to what it is, which is a little bit annoying. It means we use the compile time checking of the arguments, but you know what you're gonna do. I still think this is fun. I balanced all my brackets there. I don't think I have. What am I doing wrong? Nice. Okay, so now we get the source code information and we get the custom logging. So I think our sort of C++ 2023 whatever logging function is nearly there. The last thing I want to do is add the logging level. So class right log level. In fact, actually, let's just call that level because it's already in the logging namespace. And then what you're going to do? Debug info warn error. So we need to kind of now pass this along. I'm going to treat error and fatal as the same thing. Again, I don't want too many log levels because I will just end up quibbling with myself over which one to use. So I'm just going to keep it simple. We're going to go for 4. If we want more later, we can add more. Let's keep it simple. What I don't want to have to do is kind of like write this loads and loads of times. So what we can do, I think we can. Okay, let's do something fun. Let's do level. All right, and level. And then what we can do is we can someone's already seen it. Someone's already spotted what we're going to do. Template class args using debug equals print level debug args. So now I can just do I probably need this here, don't I? That's what it's complaining about. So level L. So now what I can do is I can make the printer templated on the actual type it wants. So at compile time, this will know, thank you, this will know what level I've asked for. So then in my log, I can just do debug, right? So let's just check that builds, and I've not wired things up any incorrectly. Nice, okay. So there's a couple of ways we can do this. I think, do we want to do it metaprogramming, or do we want to use const expr if? What are people's thoughts? Metaprogramming or const expr, or if const expr? I don't know what the delay is on me talking and getting a response, but I've not seen const expr if. Right, that was the. Am I going to do a custom window frame with functionalities, buttons, etc.? I mean, I will add to the Windows class as we need to do it. I'm not going to add a load of stuff into it. But yeah, we'll kind of get to it. Okay, fine. So let's do char C. Nope, let's do auto char equals C. Right, and then do if const expr L equals level debug C equals D, and then we can have here C. So now we get that it's a debug, and then we can do that. It doesn't have to be a char. It's just what I chose to do, and then we can just do that for all of them. So this will take we can now add all these as many log functions as we want super easily, because all we have to do is just add a using for each one. So debug info warn error, and these are just info warn error, and this is pretty it's a stateless logger, so it doesn't have the concept of sinks or sources, it doesn't have the concept of formatters, it doesn't have the concept of a minimum level. We can always add that later, but I think as kind of a modern C++ way of doing this, I think this is kind of fun. People are saying they don't really understand templates, and this is kind of a good way to have a bit of a play around with it. I don't think there's a const expr switch, unfortunately, so I think we literally just have to do the manual way of doing it. Else debug info warn error, and then we can have, and we can add control characters, and because we have compile time access to this, we could add control characters if we wanted to color it, for instance. Just make an array with the letters and access it with enum. Yes, that then does assume we will always have these in. It does tie the order of these to be the same, as in the order of the array then has to match the order of these, and it assumes that we can't add any custom numbers to this, which is fine. I just avoid that dependency by just doing it manually like this. I guess std map is also const expr. This should. So maybe we can do that. Anyway, I'm just kind of doing this off the top of my head. This is just a way of doing it. Yeah. Maybe when we get in C++ 26, when we get reflection, we could just reflect these out and do it. That might be fun. So debug. So let's just check all these work. Info warn. I don't really want to spend more time on writing a logging function than is absolutely needed. Because again, I think this is just a bit fun to play around with at the end of a stream rather than being like the thrust of what we want to be doing. But hopefully it's kind of interesting to people. Boom. Streaming till 24 hours? Nope. Streaming till almost exactly 2 minutes time, I imagine, by the time I've commented this up and finished chatting, because that's all I really wanted to do today. I was going to go through and integrate some of these logging functions, but let's do that another time. We'll add those as we go along. At least we've kind of got the we've got the framework now, and it's kind of like it was one of those things where we had a little bit of time left at the end of the stream. It was too early to end, but too late to kind of start anything big. So I thought it might be fun to play around with some templating stuff. You know, if you've not seen deduction guides before, it's a useful thing to be able to do. And I don't know, I think it's kind of fun. Yeah, we could spend all day optimizing the templates and that, but I just wanted to sprinkle a few little things in that people might find interesting. Let's remove these, and we know we're not going to use this, so we'll just delete this one. I probably don't need the length either. I'm not too fussed about the length. Again, I imagine as we go forward, we will actually cast these to meaningful types rather than just being integral numbers. But for today, I think this is kind of a good starting point. Well, I don't understand. So is the issue that you just don't like that it's the default icon? Because I must admit, it doesn't bother me. And it's in the nicest possible way, it's reasonably low on my priority list. Maybe if we get time at the end of a stream, we can look at doing it. But yeah. That did not close it. Okay, let's have a look. So we wanted to add. Let's commit add OpenGL debugging. Commit add logger. Commit integrate. It's not really integrated, it's a bit of a lie because we only put it in one place, but hey ho, it's there, it's ready for us to use. Push that up. What's going on? Hello? Git? Hello? I don't want... What are you doing? Yeah, so yeah, I mean, I know it uses like the Win32 resource center. It might be fun to use the resources going forward at some point to pack in all the game's resources so they can just, like, again, you just ship a single executable. Yeah, I don't know what happened there. That was weird. I just wanted to push up my code. Okay, can I tag this? Stream. I really should have checked this before I committed to writing a tag. I think it's stream 4. Oh, fine. Okay. Okay, that's all I had. Hopefully that was fun. I hope everyone enjoyed that. Thank you very much for coming along. Next Sunday? Yeah, next stream. Also planning on to be a Sunday. Oh no, I haven't fully decided what we're going to do. I think we need to do some more. We need to progress. There's only so many streams where you can't actually progress the visual bit. We need to progress. Oh, Jesus, what's going on? We need to progress this. So I think the next order of business is to do a mesh render a cube, enable the depth buffer, render a cube. Start building out some of the maths primitives so we can get it to move and rotate, and then do basic like Lambertian lighting, like a super simple like directional light to get something visual, and then from there we can start adding all the fun stuff like fancy effects and stuff like that. But yeah, that's all I got. Thank you very much for coming along. I've had a great time. Hope you have too, and I will see you hopefully on Sunday. Thanks very much.